This video is going to go over page 36 of the workbook, which talks about certain formulas that we're going to need to know for polygons. These formulas are so important that I've been telling my class to write them on their formula sheet. You do have room to write it right here, but because I write so large and the screen's so big, I'm going to write them on a different page. But this is the chart that you should have in mind. You should have a sum each on a regular polygon. So remember, the word regular polygon, that means all the sides and all the angles will be equal. So you make this simple table here, and you have interior and exterior angles. So the sum of interior angles, there was this formula that we learned, n minus 2 times 180. So remember, that's how many triangles you could form in the interior of a polygon. The sum of exterior angles, regardless of how large it was 360 degrees. And whenever we had to find each, we just used the same formulas as above, and we divided by n. We're dividing by the number of sides. Remember, each angle is equal on a regular polygon. Each side length is also equal. So once again, make sure you write that in this area right here that I circled. If you looked at a prior video, you should have seen that we need to write SOHCAHTOA right here, because everything here deals with right triangles, this whole section. You should also be sure to write the distance, midpoint, and slope formulas, as they're going to really help you solve problems on the SOL. So let's take a look at number 1. It's asking us for the measure of angle ACB. This one is, there's a property we learned earlier in the year. It said that we add up the two remote interior angles. That's the ones that are far away from this exterior angle that we have, 5x plus 10. And whenever we add up those remote interior angles, it's going to equal the exterior angle. So all we do is solve for this. And when you do that, you get x is equal to 10. A lot of you might want to stop here, but we have to solve for ACB. So angle ACB is this one here. So let's call that y. In order to solve for that, I need to plug 10 in here. So I have 5 times 10 plus 10, and that's 60. So if that angle is 60, I know that the one inside has to be 120, because they're a linear pair. They have to add up to 180 degrees. So let's keep going. Let's go to number 2. It says we have a regular hexagon. Since we have a regular hexagon, there's a pretty good chance we're going to be using this formula here. What is the measure of angle CDQ? CDQ is on the outside, so that means it's an exterior angle. So we're looking for each exterior angle on a regular polygon. So that's just going to be 360 divided by n, which is the number of sides. So our final answer is 60 degrees. To do number 3, we have a pentagon. We need to label some more information. We're given that E is congruent to C, so that means E is going to be 100 degrees, and D is congruent to B, so that means D is 105 degrees. And we need to solve for angle A here, angle EAB. So I'm going to add all these up. I'm going to have x plus 100 plus 100 plus 105 plus 105. And what is it going to equal? I'm taking the sum, right? So I'm finding the sum of interior angles. Again, n is the number of sides. So the number of sides in a pentagon is 5. So I'm going to take 5 minus 2 times 180, and that means the sum of my interior angles is going to be 540 degrees. when I combine like terms, whenever I add all these together, I get x plus 410 is 540, and I just subtract 410 from each side to get x is 130. That's it. If you have any more questions, please feel free to ask, and make sure to watch the other videos to help you with the SLO.